Good morning. So I wanted to go over a few things related to Vivado to Xilinx SDK code transfer for the AXI GPIO and the Mio Gpio that we were doing this week. Okay, so here is a block diagram similar to what you did yesterday with one AXI GPIO, which is the 5 buttons. One AXI GPIO with 2 channels. Channel 1 has the switches, the 8-bit switches, and channel 2 has the 8-bit LEDs. Ignore the timer for now. This is something you'll add on next lab to your project. Okay. So let's just focus on this. And also within the processing system, I have enabled the MIO so that we can turn on and off the LED on a push of a button as requested in the handoff. Okay. So from here, I'm going to export my project, and when I export my project, here it is. I've already started writing code. So let me give you a quick rundown of what you saw in SDK, so that you have a good understanding of what happens when you create a new project. Okay. So when a new application project is created, typically these two things are not there. This design 1 wrapper hardware platform 0 is there. What that is referring to is the design you've created on the Vivado end. So this wrapper has the bit file that you generated, as well as the hardware definition file of things that you added. So if I was to explore in this hardware definition file, the HDF file, what I would find is I should see there the AXI GPIO I had added. So let me just run through down here and see if I have an AXI GPIO right here. Switch and LED, that's an AXI GPIO. I should also have another one for buttons somewhere. I have one for buttons as AXI, as well as for a timer. So this particular one is the hardware definition export of whatever it is that we had done on the Vivado side when we were doing our design. Now we create a new application project. In the process, we create a C code. And let's start with some of the header files. What does the xparameters.h file have? This is a key file. This file has all of that hardware definitions embedded in it. So there's two ways to go and launch and see what is inside here. The one I like on Eclipse is to hold on to the control button on your keypad or your keyboard, control. And then if I move my mouse around, this thing becomes a hyperlink. So I can click on it and it'll open up the xparameters.h file for me. In the SDK window on the right hand side, you get an outline of the major variables or things that are on that particular file. So what is this file all about? Well, this file is a header file that describes this information so that the C code can actually access it. So let's go in here. A few things that you're going to find here in this header file is the device ID. The device ID typically starts with xpar. So xpar is how the device IDs typically start. So you'll have the device ID. Remember everything that we add on Vivado on this end. So let me bring up my Vivado real quick. Everything that we add on Vivado is memory mapped as far as this ZYNQ processor is concerned. So these buttons and switch and LEDs are memory mapped IOs. So if I click here, I should be able to see somewhere around here my location, address, and so address editor right here. So I can see what the beginning address is, the end addresses, and so forth for the different things I have, right? So basically these are memory mapped IOs. So this header file is going to let our C code that we're going to create later on know what the name of the device is, what the base address is, and what the high address is, meaning the overall memory space it occupies. And then it has a few additional things. So let's go here and find out what other things are there. So by convention, the buttons, SW, and LED, all caps should be in the device name. So I'm going to search for buttons here. Okay, all right, here you go. xpar buttons device ID. So that's the name of the device ID for the buttons. Similarly, I see xpar switch and LED device ID. That's the device ID for the switch and the LEDs. Okay, so the header file xparameters.h has all of that information. Now the question is, what is the name of the device for part C, where I asked you to turn on the MIO7 LED that's connected to LD9 when I press the button PB1, which is MIO50. So when I press that button, I wanted you to turn that light on. Well, where is that connected? It's connected to this ZYNQ through the fixed IO right here. Okay, so, well, what is IO? Well, general purpose IO. So let's search for that device ID. What is that device ID going to be called? That device ID, let's search for GPIO. And what we're going to find, well, this is not the GPIO we're looking for, because this is the switch and the LED. So let me find again. Find next. Next. This is buttons. So that's not the GPIO I'm looking for. This is the GPIO I'm looking for. So here is the device ID for the GPIO that's going to be connected directly through the MIO to ZYNQ processor. The PS7 stands for Processing System ZYNQ 7. Okay, the ZYNQ chip that we have is called the ZYNQ 7020. The PS7 is referring to that. So the device ID for all MIO peripherals that are connected, to my MIO directly to the processing system is this. Okay, all right. So that's the device ID I need. So I can use that. And here's a redefinition of that particular device ID. If you notice that xpar PS7 GPIO 0 device ID is also redefined as xpar xgpio PS0 device ID. Okay, all right. So either way, you can use this device ID or this device ID. It doesn't mean that essentially they're the same. Okay, so we're going to start with that. So that device ID. So when we need to use the GPIO GPIO, we can use this ID or this ID. You can use either of these. Okay, so here, if you look at this, I actually used that particular device ID. Okay, now let's walk through more. There are two header files. One for the xgpio.h. This is the header file. So this is the header file for AXI GPIO. This one right here called xgpiops is the header file for the MIO GPIO. Okay, so let's look at xgpio. So if I control click again, so what did I do? I held the control key and clicked on it. I see all the functions that are associated with our AXI GPIO right here. Initialize, set data direction, discrete read, discrete write. Those were the four functions you saw in the example that I had on your handout. So for example, initialize. Well, what does initialize one need in terms of its parameters? You need to create an X device, right? xgpio, that's a structure. xgpio is the structure, as I indicated yesterday during our lecture. X, all hardware start with an X for Xilinx. So xgpio is a structure. This structure basically holds the base address and whether the device is ready and initialized, if there's any interrupts that's available, and if there are multiple channels or not in this particular case. Okay, so let me go back here. So if I now go and figure out what do I need, so xgpio, what are the different functions that I might need? Or initialize. I need to set the data direction to input or output for every pin, and I need to either read or write from those. So it looks like discrete read, discrete write, set data direction, as well as initialize are key. So let's see. So for AXI GPIO, I have xgpio initialize. How do I use it? Again, if I want to know that, what this function does, I can go up here, I can click on xgpio initialize. It'll tell me I need the instance pointer and the device ID. So my instance pointer are these. So initialize with ampersand SWLED, and that was the device ID from xparameters.h. Similarly, I initialize the button. Similarly, I initialize this button right here. Okay. Now, I don't need to reinitialize again for LEDs. Remember, this device contains two channels, one with the switch and one with the LED. We're initializing this block, so you only need a single initialize. All right, now for SWLED, we need to set the data direction. Let's look up here. Switch data direction should be input. LED data direction, as far as the processor is concerned, is an output. So we need to set two separate data directions. Channel 1 as an input, channel 2 as an output. So let's go take a look at that. So here I have set data direction. That's the instance pointer. Let's go look at what set data direction is looking for. So control click again takes me to this. And if I read these comments right here, it says channel contains a channel of the GPIO. It's either 1 or 2. So you have to read what these parameters should be. So the channel value is either 1 or 2. Direction mask. Direction mask is a bit mask specifying which discretes are inputs and which are outputs. Bits set to 0 are output. Bits set to 1 are input. All right, let's see. Switch LED. Channel 1 was the switches, so input. Channel 1, so that's specifying that that's channel 1. FFFF, that's 32-bit. Right? So all of these 8 Fs make 32-bit. It's essentially saying F is 1111. F in hexadecimal is 1111 in binary. So essentially it's saying every single bit in channel 1 is associated as an input because 1 stands for an input. Similarly, the channel 2 is connected to LEDs. We want each of the LEDs to be set up as an output, hence 0x0. Or if you want, you can do 0x00 like this if you want to be absolutely writing 8 hexadecimal digits, which translates to 32 bits. Okay. So we've set the data direction for both channels of the switch and LED block. For the button, there's only one. So for this one, we only have one direction. The buttons are inputs to the processor. So we only have one channel for that. So I can go here and I can say button channel 1, set it as an input. Okay. So we've initialized, we've set the data direction, and then we can write discrete read from the switch LED channel 1 and write to channel 2. That's what's happening here. Okay. So this is what I asked you to do as a part for part, I believe it was part B or C of your of the lab exercise. Now the final part of your lab exercise, says work with Mio Gpio. All right, so what you're asked to do is set this up so that when you press this Mio 50 button right here, this particular LED on the breadboard will actually light up. And I give you some hints about what you might do. You can look at examples on how GPIO-PS system is set up. But let me quickly talk about that here as well. So now, xgpio.h, like I mentioned, so xgpio was the header for AXI. This is the header we're looking at for this particular portion, part C. Okay, so here I am. Click on this. There are a variety of functions right here. So let's take a quick look. So in the AXI GPIO, there was a xgpio underscore initialize. I'm not seeing that anywhere. However, I do see that there is a configuration initialize as well as there should be a lookup configuration. Now those, as I mentioned yesterday in class, are typical ways of initializing every Xilinx parameter. Okay, so you look up the configuration, and using the configuration that was looked up, you initialize that particular device. So for part C, I'm going to walk you through what you would be doing. So I have a xgpio.ps my GPIO as well as a configuration pointer right here. So these 2 points right here are specific, right? So for the Mio GPIO, okay, these 2 are for the Mio GPIO, right? And I also created a integer called status so that I can look up if the configuration lookup was successful or not. Okay, so let's go take a look here. So up until here was for the AXI GPIO. And now let's go here. Since there isn't an initialize function directly in the AXI GPIO, I have to go through and look up the configuration. Remember, this was the device ID for the Mio Gpio. I look up the configuration based on the device ID. Let's see, that's what the lookup configuration says. If you just put your mouse, hover your mouse over that particular function, you will see what that function is looking for. So it says device ID right here is one of the parameters. Configuration initialize, what is it looking for? It is looking for the instance pointer, it's looking for the configuration pointer, and it's looking for the effective address, which is basically the base address that's in the configuration pointer. Okay, so you look up the configuration of the device, and using that configuration pointer, initialize that particular device. Now, what does the status do? If you look at the configuration initialize, status is basically XST success or failure. Okay, it's letting you know if the whole thing was successful or not. All right. Now, in the case of the AXI GPIO, we were working in a collection or a bundle of pins at a time. The Mio GPIO is not just the LEDs and the switches, it's also the I2C and the SPI and the CAN bus and the SDIO and other different inputs and outputs. So we want to be very specific about setting the direction of a particular pin. In our case, the pin on the JetBoard right here, if you look at the JetBoard itself, it says MIO7 is that LED right here. It says MIO50 is this push button, and MIO51 is the next push button next to it. So we are looking at pin 7 and pin 50 for this LED and button pair. Okay, so we just need to do individual pins. So again, if I go to xgpio.h and look through all possible functions here, I see set direction, I see read pin, write pin, I see set direction for a particular pin. So let's take a look at what set direction for a particular pin does. It says instance pointer to the GPIO instance. Pin is the pin number to which the data is to be written. In our case, 7 or 50, depending on whether we want the direction for the LED or the button. And be careful, direction is the direction to be set for the specified pin. 0 are for input, 1 is for output. 0 is for input, 1 is for output. Now, this is exactly opposite of what we had done earlier with the AXI GPIO. So it's important, very important to read the different parameters that have been set up in the library for input, output, and so forth. So always get in the habit of reading these. Okay. So my board test, I'm going to go back here. I'm going to set the data direction for LED to be, so 7. I'm going to set the LED to be an output. So my GPIO, that's the pointer for the xgpio.h. Pin 7, I want to set it as an output. Pin 50, I want to set it as an input. Okay, and this time around for the GPIO.h, instead of reading the whole read and the write, we're going to do read pin and write pin. So if I go here and look for it, I see read pin and write pin. So you're going to use those two functions to basically read the state of the push button and write to the LED. So my suggestion to you is to basically, you can look at the write pin and the read pin right here. So for this lab, I just want you to be familiar with some of these things. How do you read a header file? How do you explore it? I want you to develop these techniques because this is exactly what you're going to do if you get into writing software at any other workplace. Okay, you'll have to dig through the header files and figure out what it is that parameters are, what is it that is happening here. Okay, so this is it. If you have tried out, basically gave away pretty much everything that is required for learning exercise 3. Watch this video, try to understand what the header files are saying, probe around. You do have to answer the final question. read through the header file carefully and answer this question. Why does the initialization of AXI GPIO and MIO GPIO look different? More importantly, what does the part B code not use the configuration pointer and look up configuration? In other words, what I'm really asking is, how come when I was using the AXI GPIO, I used the xgpio initialize function, whereas both in the slides yesterday as well as the initialization of the GPIO.PS, I had to look up the configuration and I had to initialize the configuration. How come this initialization is multiple step and required what I told you needed to be done in the slides yesterday, and how come this AXI GPIO initialization was just one single function? Okay, you need to thoughtfully answer that for your learning exercise